Good evening, Northern Colorado. This is Whiskey Zero, Delta Delta Zulu. My name is Nave, and I am net control for tonight's Northern Colorado Amateur Radio Club TechNet. We meet here on Mondays to discuss topics of a technical nature to the amateur radio community and to get information out there and ask questions of our Elmers. Tonight we are discussing what is the difference between the various modes, FM, AM, single sideband, and let's start by taking some check-ins. If anybody would like to check into tonight's TechNet, please call.
Alpha Echo Zero Alpha Foxtrot.
Kilo Alpha 6 Echo Tango Echo, Jim Loveland.
Alpha Echo Zero Alpha Foxtrot, Tim in Lakewood.
Zero Bravo Quebec, Daryl in Longmont.
Alpha Echo Zero Alpha Foxtrot, Tim in Lakewood.
Oh, let's start by acknowledging AE0AF Tim and KE6ETE Jim. Daryl, I heard your name, but I didn't catch the call sign. Will you come back with your call sign?
Alpha Echo Zero Bravo Quebec, Daryl in Longmont.
And good evening to AE0BQ. Any other check-ins, please call.
This is Kilo Echo Zero Lima Charlie Kilo KE0LCK, the other mic from Windsor.
This is Kilo Zero Papa Romeo Bravo with Kilo Zero Lima Alpha Oscar, Phil and Luann in
So in avionics, we definitely use that so that we can make sure that the closest plane to the people listening are able to be seen. I'm sorry, heard. Does anybody want to add to that? Please call.
Yeah, how does mic gain, the setting on your mic, factor into that?
I can take a stab at that, Dave.
Yeah, go ahead, Greg.
So whether you're doing AM, FM, or sideband, your microphone is how voice is turned into an electrical signal in the first place, and that's amplified and then applied to the modulator in your transmitter. The more amplified or the more microphone gain you have, the more strongly modulated your signal will be, and the clearer it will be up to a point. Obviously, if your microphone drive is turned way down low, even if you have a good solid carrier, you're not going to be putting out a lot of signal. The problem is if you overdo it and have too much microphone gain, you begin to distort your audio or clip, or in the case of FM, your signal becomes wider than it's supposed to be for your channel size, your allocation. If you're supposed to be in a 10 kilohertz channel and you're 12 kilohertz, you're going to be spilling over into adjacent channels. So that's why gain is important. You want enough to have good modulation, but not so much that it's clipping at the top of your voice peaks, and 0 EMP.
Okay, so when you're talking clipping, if you look on your radio and you have an audio spectrum there, you'll see where the top of your signal begins to flatten out?
Exactly, depending on exactly what your display is showing. But if you look on an oscilloscope and you're actually looking at either the output of the microphone amplifier, an amplifier can only go so high if it's running, for instance, we'll just throw some numbers around, if it's running on a 12-volt power supply, absent any transformers or anything like that, it can't put out more than 12 volts. And if you have so much gain that it's trying to, instead of having sine waves or symmetrical waves, they're going to be flattened out on the top because they can go up so high and then they can't go any higher. And if you're trying to amplify, the voltage level of your signal above what the amplifier can do, that's when you get that flat topping or distortion or clipping.
Okay, I understand that. What would you say starting off to adjust your mic gain would be a good spot to start? Would you say 50%?
I would say whatever the factory default is for that radio, and I think it's usually 50%. Now that's another nice thing about these online software-defined radios is if you can find one that's not right next door to you, but close enough that you can easily transmit into it and then watch online and monitor your own signal from that remote receiver, you can play around with a lot of your adjustments like microphone gain and compression and things like that. And you can see on the waterfall spectrum of the online SDR, you can see what's going on with your signal, and and you can even listen to it, although it's kind of hard to listen while you're talking, but you can have someone maybe in the other room watching and listening to your signal, and you can, that makes it a lot easier to fine-tune your own equipment that way, your own transmitter.
Okay, got you. That makes sense. I think I will try that.
Yeah, thank you for that. Any other questions?
I have a question about technician class privileges in 10 meters for sideband phone, KE0TDK.
Yeah, go ahead, Ralph.
I have a good friend in the Midwest, and right now my current level of privileges, the only way I can communicate with him on the radio via phone would be 10 meters. And he's a little bit hesitant to go forward, in part because of conditions of the band. I mean, it's a daytime proposition, from what I understand. And also, he feels it's too adjacent to current Citizens Band frequencies. And I would just wonder if anybody works 10-meter phone sideband, their take on that. KE0TDK.
You broke up a bit there in the middle. Do you want to just go ahead and repeat your question one more time?
Yes, a question about basically sideband on 10 meters and best time to talk to, say, several hundred miles away, and also is interference with Citizens Band frequencies an issue for anybody who has worked this band for a single sideband phone?
Does anybody want to take that?
EMP?
Go ahead, Greg.
Yeah, I monitor a lot of stuff that's outside the amateur radio bands, and the CBers modify their equipment, and they use amateur radio equipment that's been modified, and they transmit with more than legal power, and they transmit outside of their allocation in the Citizens Band. But I have not seen them come into the amateur 10-meter band. I've never seen one case of a CB bootlegger coming into our allocation, so that shouldn't be an issue. Propagation's really not great right now, this part of the solar cycle, but I know there was an opening the other day, and for a few hundred miles away with good antennas, you might be able to get a path. Otherwise, next spring, try 6 meters and 0 EMP.
Yeah, the time on the solar cycle really makes it a challenge sometimes to get through on many of the bands that we get. I imagine that's why we get so many of them to work with, because during the low solar cycle, it gets it to be a challenge to get that signal out. Does that answer your question, Ralph?
Yes, that's all helpful, and I'll hold questions about antennas to a later session. I certainly have a lot of things on my mind about antennas right now, but I'm hoping to extend my privileges in the spring to general class, and so that'll give me some more latitude as far as phone, and then I can look at some different equipment to to better meet my ideas.
Well, we will definitely have a open question portion at the end of the topic here, where your antenna questions will be a good point time for those. Was there any other questions about the modes that we have discussed so far? Hearing none, let's move into the difference between the standard FM and narrowband FM. Greg, do you want to touch a bit on that?
Again, it's going to depend on in what context you're talking and what radio you're talking about, possibly as well. And as far as like the public safety bands with their narrow banding, I don't know how that aligns currently with us. But the commercial FM broadcast, the music, 88 to 108 megahertz. Each one of those channels is like 200 kilohertz wide because it's a real high fidelity stereo signal. Those are very wide. So when I think of wideband FM, that's what I think of. Then you have this term narrowband FM, and to me that's anything that's not wideband FM. So what we're using right now, I would call narrowband FM. And on some receivers and some transceivers, that's how this bandwidth we're using right now is labeled. Then again, there was some narrowing of that recently in public safety communications to make it even take up a little bit less space, and I don't know exactly what that definition is, and if that's what people mean now when they say narrowband versus a few years ago. I don't know.
Well, I believe it's the Bofang that has the narrowband. Oh, let me just... this is Whiskey Zero Delta Delta Zulu. I'm net control for tonight's Northern Colorado Amateur Radio Club TechNet. Like I was saying, I believe that the Bofang has a narrowband FM mode, which is half the bandwidth of the standard FM. And what ends up happening with a lot of amateurs that get stuck in that narrow band mode is that they come across really quiet because the allocation gives us so much bandwidth on each band. And as we're transmitting less than that, it turns into a quieter audio on them. So some of those Bofang radios, I believe that it is, you have to look into the modes and actually change them to the wide FM mode. Otherwise, you sound very, very quiet.
Yeah, and again, that's where we get into what radio are you talking about and what application and what radio service are you talking about. I think a lot of these FM radio, other than the broadcast music stereos, just the communications radios, used to use 25 kilohertz channels, and that was partly because the filters were not that great, especially in mobile equipment and handheld equipment. So they just made the channels wide. So every time you went up or down in frequency, it was in 25 kilohertz steps. Quite a long time ago, they cut that in half, and it was just because of better filters. There's still plenty of room at 12 kilohertz or even 6 kilohertz. There's plenty of room for a voice signal. I was looking yesterday, actually, with an SDR at the National Weather Service VHF FM voice broadcast in preparation for tonight's topic, and it looks like that is 6 kilohertz, and that's still plenty of room. Now, if they've gone narrower than that in some applications now, I think they may have, for analog public safety radio, I think has gone even narrower than 6 kilohertz now. But I don't know exactly what they've gone down to. N0 EMP.
Yes, thank you for that. Any other questions about FM, AM, single sideband? All right, let's move into some of the digital modes. You touched on the FT8 and how it's able to be picked up below the noise floor. How is that capable of doing that, and what is different between the digital mode like PSK versus the voice modes?
EMP.
Go ahead, Greg.
Well, there's a whole bunch of these digital data modes, and here I'm not talking about digital voice like D-Star or DMR. I'm talking about computer to computer, keyboard to keyboard, and sending text back and forth, and some other things like pictures and things. And since they started using, it used to require dedicated hardware to do this, radio teletype and other formats used hardware that was designed just to do that. Probably about 20 years ago, people started writing software that could use the sound cards in common computers to create and decode these waveforms, these digital modulation schemes to pass data. And that's where your PSK31 was probably one of the first sound card modes, and then it was adapted to radio teletype and a lot of others. And now seems like everybody that knows how to program and is an amateur has come up with their own mode, and there's hundreds of them now. In general, the concept is the narrower the bandwidth that your mode uses, the better it can get through the noise, but the slower it's going to be. So PSK31 is 31 hertz wide, and it sends data at about the same speed that I can type, and I'm not a good typist, but I can pretty well keep up with it on the keyboard. Some of these other modes like JT65 and FT8 are super, super slow, and it's because they're using an incredibly narrow channel and a lot of error correction coding and redundant, sending the same thing over and over to double check that it went through properly and correct errors on the other end. So they become very slow modes, but they can get through. So that's it in a nutshell. N0 EMP.
Comment.
Oh, that last station, I didn't catch who that was, but go ahead.
It's W0LEV. There may be some question between how you set your bandwidth, which of course Joe Taylor recommends 2.83 kilohertz, and what Greg just commented, very narrow band. You need to set your receiver bandwidth for FT8, JT65, and so on at 3 kilohertz to include all of those stations which may be transmitting on the designated frequency. However, the very narrow bandwidth is embodied in the software, well, firmware of JT65, FT8, and so on. So in spite of the fact that you set for 3 kilohertz, the routines in the FT8 JT65, well, WSJTX applications, those embody an extremely narrow bandpass, so don't confuse the two. W0LED.
Yes, and speed definitely gets into it. I think that the JT or FT8 has a 15-second round. Am I correct in that?
Yeah, you're correct. And the reason JT or FT8 came about was because people lost patience with JT65 on the 60-second turnaround. It does not crawl as far into the noise as JT65 because of the shorter time to do error correction on multiple transmits, W0LED.
Yes, and thank you for that, Dave. This is Whiskey Zero Delta Delta Zulu net control for this evening's Northern Colorado Amateur Radio Club technical net, and the JT65 and FT8. The number on the back is the number of tones that they're actually using for the transmission. Is that correct?
I can't confirm or deny that. Greg, do you have any more info on that?
I know that in some of the sound card modes, like MFSK8, MFSK16, MFSK32, that's correct. I don't think Joe Taylor used that. For instance, I don't think there's 65 tones in JT65. So I don't think he uses that. I don't know what his numbers mean. But in some of the other modes, and it's another thing, a lot of these sound card modes, you'll have one mode, and it'll have 8 different formats for that mode. You'll have different numbers of tones, different bandwidths, different speeds. So it can become difficult to tune in and decode because you don't know, unless you know ahead of time what the guy's sending, you don't know which options to select. But no, I don't think in the JT stuff, the Whisper stuff, I don't think that's the case. And 0EMP.
Very good. Any other questions about the modes we've covered so far? Please call.
Alpha Echo Zero, Alpha Foxtrot. I know that FT8 is really popular because of the speed of contact that can be made, but in a situation, what's probably the most practical as far as actually sending real traffic as far as the data modes?
Ooh, good question, Tim. Greg or Dave, do you have some input on that?
For keyboard-to-keyboard chat, PSK31. If you're more interested in emergency communication and sending like pages of documents and things like that, you probably want to look at MT63. Mike Tango 63. It's a lot faster, uses more bandwidth, but it's still a very robust mode. And a lot of the different emergency services, amateur, not areas per se, but amateur radios that are involved in emergency communication use MT63.
Is there a particular piece of software that you use with that?
There's some free software called FL Digi, Foxtrot Lima, Delta India, Golf India, FL Digi. It works in Linux, and I believe, Dave, you probably know it works in Windows. And it covers a bunch of different modes, and it's free. There's a bunch of other free software for the sound card modes as well, for Windows, Linux, Mac, Raspberry Pi, all sorts of stuff.
Thank you. Alpha Echo Zero, Alpha Foxtrot.
N0WIQ with a comment.
Go ahead, Carrie.
Somewhere in the documentation there is a formula for bandwidth versus data rate, so the faster you send data, the more bandwidth you use and all that kind of stuff. I just thought I'd throw in that comment.
Thank you for that. This is actually the first time I've heard of MT63. Is that used very commonly, or I haven't heard that before?
I don't know that it's used currently in Colorado through Aries or any of the other MCOM people out here. A lot of other states use it. I think Mars used to use it. They might still use it. I've read a lot of write-ups on it, like in Monitoring Times, which is an online magazine I subscribe to. It's a monthly. If you're interested in what's going on in radio technology outside of amateur radio, it's a good publication to subscribe to, Monitoring Times. But there's been a lot of good write-ups on it. I know OJ has had some past experience with it, I think with Mars years ago.
Yeah, that's definitely interesting. I'll have to do some further reading on that. Any other questions about digital modes?
Does anyone... A0BQ MT63 was originally developed and by whom?
No, we had a bit of a double there. I got AE0BQ. Do you want to ask your question? Then we'll come back to the other station I didn't catch a call on.
Yeah, thanks. This is AE0BQ. So, are there any modes, digital modes or whatever, digital modes that can use a broadband, a big chunk of spectrum to improve the transmission speed? In other words, more bits per second with more bandwidth used on this, in the RF spectrum. Because I've looked at that, and everything that's on HF is just kind of lame. It's very disappointing if you want to send something like images. So I guess there's satellite modes that I don't know much about, and I guess there's pause for reset. And I guess there's slow scan TV and things like that, but those are still fairly low resolution and low bandwidth. If we wanted to send, megabytes of information using a massive amount of spectrum, what's the best way to do that? I know we have a lot of spectrum up in 50 megahertz and higher, certainly up in 1.23 gig. 5 centimeter? Anyway, that's my question. Are there ways to send a lot of data quickly using more RF spectrum? AE0BQ.
EMP.
Yeah, go ahead, Greg.
Short answer is yes. Long answer is we're limited by regulation as to our baud rate or data rate, bits per second, on the different bands. And I think primarily in HF we're limited to 300 baud, and like Carrie alluded earlier, it's a trade-off of data rate versus bandwidth. And there's not a lot of room down in HF, and we have to share it with everybody else and all the other modes. So we're limited in HF to our data rate or baud rate. As you go up higher in frequency, it goes up from 300. At some point it's 19.2K, which isn't bad. Then it goes up even more. You get up into microwave region, and you've got very wide bandwidth available. Our repeater linking for our repeaters is over 5 gigahertz microwave, and we're using commercial off-the-shelf equipment, but we're using special firmware, and we're using amateur portions of the 5 gigahertz band. And we have hundreds of megabits per second of bandwidth on our microwave link. It carries all the voice from our voting receivers, all the control functionality, IP cameras on a couple sites, and there's plenty of bandwidth to spare. So yes, you go up into a band where you're allowed to use a lot more higher baud rate, and you can go to town and 0 EMP.
W0LEV.
This is Whiskey Zero Delta Delta Zulu with the Northern Colorado Amateur Radio Club TechNet. Go ahead, Dave.
Yeah, to further on Greg's comments, this is why the commercial people have gone to fiber optic, certainly not over the air. There we're measuring bandwidths in terms of the thickness or fractional thickness of a human hair versus something you can measure on a ruler, which is our microwave frequencies. That's precisely why the commercial people go to fiber optic. Higher frequency, broader bandwidth. W0LEV.
Hopefully that answers your question, Daryl. Did we get you covered?
Well, sort of. I kind of already knew that those things were available. Certainly I don't have any budget to experiment in the 5 gigahertz range. I imagine that equipment is pretty darned expensive. And hard lines and fancy waveguides and resonant cavities. So to the amateur extra, right? Here's a question. What is the fastest I can send as a licensed amateur extra? What is the fastest that I can send data across the airwaves using whatever spectrum is legal? Over. AE0BQ.
Well, we're using micro-tick 5 gig dishes that are about 12 inch across, and I think they are less than $200 a piece. And our longest link is from Buckhorn to Greeley or Horsetooth to Greeley. I think Buckhorn to Greeley is 33-mile link, and that's, better than 100 megabit per second. Otherwise, look at 900 megahertz and up, and you'll have to pull up the regs and see how fast you can transmit data in those different bands. I don't have that right in front of me. But start at 900 megahertz and go up from there and take a look. N0 EMP.
And in HF, you said it was around 300 baud?
I think so, and there might be other limits in some of the bands, and it might, 10 meters might be faster, I don't know, but that's what came to mind was like a 300 baud limit in HF in general. I don't know if there's anything more specific. I wouldn't go and do that without looking first because I'm just talking off the top of my head right now.
Yeah, thank you for that. Does that get you covered, Daryl?
I'm sorry, you guys were talking about HF. I don't think that's in what I'm thinking of. So it sounds like I have to research the whole 5 gigahertz, implementing hardware and dishes, and so in practice, the answer to me is no. You can't get there from here as a licensed amateur extra unless you want to spend buku bucks buying all new gear to do 5 gigahertz. Transmit and receive using dishes. And it's, of course, line of sight, so... Okay, thank you. AE0BQ.
Comment?
Thank you for another comment.
Okay, we had a couple comments there. W0LEV, I got you first. You want to go ahead?
Yeah, just a quickie. The license class really, outside of the 300 baud, doesn't have much to do with it. Your license class, as an extra, doesn't buy you anything on the higher frequency bands than a technician class. Your privileges are identical. W0LEV.
Thank you for that. And Carrie, you had a comment. Go ahead.
The only digital mode I have much experience with is D-Star, and it uses a 10 kilohertz bandwidth, and it also uses a dual-tone digitizing mechanism for sending data around. So, dual-tone data transmission has been around for a long time. That was what was used for packet, as a matter of fact. So they did that with an AX25 format. So what can I say? That's the only two things that I really know about is things that worked on repeaters and stuff like that for digital stuff.
Well, and the other thing that I would add is that I think you'd be surprised at the cost effectiveness of the 5 gigahertz equipment. It's really not as expensive as it may seem to be, but it is definitely limited to line of sight. That is definitely one of the quirks of the higher frequencies. We had a station double with Daryl. Other station, do you want to go ahead?
KE0TDK. I was wondering if anybody knew the original development or origin of MT63, any historical background on it, just as a matter of just pure curiosity. KE0TDK.
Ooh, Greg, do you want to touch on that?
Off the top of my head, I don't know. The first thing I would do is I would see if there's a Wikipedia page for it. There very well may be. If there's not, then I would just Google it in general and look for some I'm sure someone has a nice article about it that talks about its history and background, but I would look for a Wikipedia article first, M0EMP.
This is Whiskey Zero Delta Delta Zulu for the Northern Colorado Amateur Radio Club TechNet. And just jumping onto Wikipedia, and there is a article on MT63. It looks like it is a mode for transmission in high noise situations developed by, I'm going to butcher this name, Paul Jeloka, SP9 VRC. It's a keyboard-to-keyboard conversation mode, it looks like, for use on HF amateur radio bands.
Thanks for the follow-on. I'll do a little bit of researching on my own in means suggested, KE0TDK.
Thank you for your question, Ralph. Any other questions with regard to the digital or the modes, all of the modes, FM, AM, single sideband, all the digital modes?
IQ with a comment, though.
Go ahead, Carrie.
It might be something worth noting, and that is that the 5 gigahertz Wi-Fi is used a lot because we have a lot of different portable computers that use it. So I thought I'd mention that because when you talk about the 5 gigahertz band for amateur radio, it has to be a little bit offset from the 5 gigahertz band that Wi-Fi uses.
Well, hopefully somebody can correct me if I'm wrong, but I think there is actually some place where the amateur band crosses into the 5 gigahertz Wi-Fi band. Am I correct in that?
Yes, you are. Virtually all of the ISM bands, industrial, scientific, and medical bands, have amateur allocations.
Grandfathered into the ARRL, but on the other hand, you know that the amateur band has to be a little bit different than the 5 gigahertz Wi-Fi band. So, I mean, it's just one of those things. The 5G, I have to assume means 5 gigahertz for Wi-Fi. And of course, Wi-Fi has gone from something like 3 gigahertz all the way up to 5 gigahertz. And they've had to make equipment that will handle all of those, choose one of those at each time. So, I mean, hey, that's the knowledge I have about it. And that's the only knowledge I have about
it. We had a bit of a double at the beginning there. LEV, do you want to go again?
Yeah, sorry about that. All of the amateur bands share with the ISM bands, industrial, scientific, and medical. We all share with those bands, and yeah, there are amateur allocations for that. And with the 5G, not gigahertz, but 5G service, they're actually looking at 100 gigahertz plus, but that's commercial people. We have allocations there as well. W0LEV.
Yeah, I definitely thought there was some crossover in the 5 gigahertz band for commercial use and amateur. But there is a lot of spectrum in the 5 gigahertz or 5 centimeter band. It looks like that band goes from 5.65 gigahertz to 5.85 gigahertz, which in all actuality is a huge amount of bandwidth on that band. Any other questions on the modes we've been discussing?
Listed W0LED.
No, I'm sorry, Dave. I doubled with you. You want to go again?
Oops. Sorry. If you look at the ARRL site, they have all of that listed there, where we can and can't go. W0LED.
Yeah, there really is a lot in the ARRL site that they cover for us quite well. We definitely appreciate that. Are there any other questions on the digital modes? I'm sorry, all modes, digital and analog modes.
KF0AAL with a question.
KF0AAL, what was the name, please?
Yeah, my name's Al, per my call sign. But I've been reading a lot about APRS, the Amateur Packet Reporting System, and it seems like there's a lot of use where it's used for GPS and tracking where your car is, but the creator of it, I read, actually said that it's not used for position reporting. I'm just wondering if anyone knows what it's supposed to be used for and how you use it that way.
It's definitely, yeah, I've read that it's not just for position reporting. A lot of people think that APRS stands for Automated Position Reporting System, and what it is Automated Packet Reporting System. There's definitely more functionality in there than just position reporting, such as weather, and you can also send messages through it. Does anybody want to dig in more to APRS?
Zero WIQ again.
Go ahead, Carrie.
Well, as I mentioned before, the AX25 data protocol that is used for packet, the automatic position reporting and all that is just a subset of that, so I'm just going on that. And then there's other selectivity is frequency you can use to do that, so what can I say? Back to net.
And I am just pulling this from the APRS site, aprs.org. APRS is not a vehicle tracking system. It is a two-way, tactical, real-time digital communication system between all assets in a network, sharing information about everything going on in the local area. On ham radio, that means if something is happening now, there is information that could be valuable to you, then it shows up in your APRS radio in your mobile. Hopefully that helps to answer your question some. Did we get you covered, Al?
Yeah, I think that was good. Thank you. That answered a lot of my questions. KF0AAL.
Perfect. Thanks for the question. This is Whiskey Zero Delta Delta Zulu with the Northern Colorado Amateur Radio Club TechNet. Is there any other questions about the various modes we've covered?
K0PRB.
Hey, Phil, go ahead.
Hey, Dave. I'm kind of sending from the basement on an HD, so I hope it's coming through okay. Is there someone who can give us a demonstration on the FM narrow versus wide banding on there? That'd be cool.
Comment?
Go ahead, Dave.
Yeah, we are not permitted FM wide on any of the standard frequencies, including this one on down. You've got to go to, I think, L-band 1200 or above for amateurs to be allowed to do wideband FM, that is plus minus 75 kilohertz, the standard commercial wideband FM on 8108. We're only permitted narrowband on these frequencies, W0 LED.
Okay, Dave, maybe I just put it incorrectly, put it out there wrong. On our HTs, we can select narrow or wide for the HT, and I know there is a difference, and it was discussed earlier. Greg mentioned it, and I was wondering if Greg said, well, it decreases volume. I think it also changes the voice structure a little bit as well. And so I was kind of wondering if there was if somebody could do a wide and narrow demonstration off of their HT.
Yeah, somebody else will have to take that. Narrow, I think, commercial people use 2 to 2.5 kilohertz. If it comes across on one of our repeaters, it's very, very quiet. And you got to turn the volume control way up to hear it. W0 LEV, somebody else needs to take that one.
Yeah, I just looked through my FT60 and I don't see a narrow FM mode on that. I know we have definitely got into that with some people who have been on a narrow mode, and it was, like Dave said, extremely quiet, and we had to turn our volume up quite loud in order to hear them. And after discussing with them and telling them where to find it in the menu, got them to turn it back on to wide, and yeah, their audio levels went back to normal so that they were transmitting at the same volume as everybody else. Does anybody have a HT that has that capability?
This is K0PRB. I just found it in my menu and switched over to narrow. Does this sound any different than it did a minute ago? I do know that when in listening to your voice there, Dave, when I switched to narrow, your volume went up considerably than when it was on wide. So it's obviously doing something on my end in receive, but not necessarily transmit.
So, Phil, I was looking at the level on my audio system here while you were talking. Do you want to switch back to narrow, and I can tell you if you're getting a different level?
I can do that. I'm on narrow right now, so I'll make sure I keep my face as close to the and talk at the same level as before. Switching to wide. Okay, I'm back, and I am now on wide rather than narrow.
Yeah, there was definitely a huge difference. In narrow, on my system here, you were getting to 0 decibels, which is about halfway up the meter. With wide, you were getting all the way up to the plus 10 decibels and right below the peak. So it was a lot clearer, and you were a lot easier to hear on the wide mode.
Okay, good to know. Yeah, I wish I could have heard that difference as well, just so I know. It makes me wonder if some people are setting their HTs to, when we say, hey, you need to get into your microphone a little bit more, maybe they're set on narrow rather than wide. We need to ask them that question as well. Good to know. It's odd that when I switched you over to narrow, though, that your volume went way up on this end, and it's like, whoa, I had to turn everything down. So it could be just the HT itself. K0PRB.
Well, and we are streaming onto YouTube at the about 1 hour and 8 minutes. If you jump onto the YouTube channel, you should, and it's going to take it a few minutes to process after the net, but you should be able to listen to your transmission on the YouTube channel, and you will be able to hear for sure the difference in your voice from your narrow transmission to your wide transmission. And speaking of YouTube, we actually have a question from Alec on the YouTube channel. How about slow scan TV or fast scan TV? Can anybody give us a little information on those modes? Yeah, I definitely haven't had a chance to play with the video modes much at all. Does anybody have any experience with the video modes on amateur radio?
EMP.
Yeah, go ahead, Greg.
Yeah, what they call slow scan TV isn't really TV like video. It's a still image, and there's a fair amount of it being sent still on HF. And again, now there's sound card software that can do it, but it scans a still photograph or a still capture in a computer screen. And it scans it line by line, and as it scans, it generates tones that represent intensity and color on each line, and it transmits those. And on the receive end, the process is reversed, and as it receives and decodes those tones, it prints line by line until it finally prints the whole picture. And I've never sent it, I've decoded it before, and it can take like a couple of minutes to send a picture that way. Fast scan TV is up 6 meters and above where there's more bandwidth, and we can use wider band, and that's actual television video signal being sent. And 0 EMP.
This is W0DDZ with the Northern Colorado Amateur Radio Club TechNet. Yes, one place that I have seen the slow scan TV stuff sent is the ISS will send pictures down from there that we can receive on slow scan TV. And I've had some of those pictures shared with me. I have never received them directly, but they are... it's definitely interesting to see for sure. And like Greg, I've never transmitted any images through amateur radio myself. Is there any other questions about the various modes that we've covered, or any modes that we've missed?
2DK comment?
Yeah, go ahead, Ralph.
I would just mention for some of our younger participants that when transmitting video, that's in the now sort of legacy NTSC mode. It's not digital HD. Probably pretty obvious at second thought, but just an observation that it's NTSC, so it has the limitations of that format.
Comment?
Go ahead, Dave.
Yeah, NTSC mode is standard. However, the Boulder Club does support both NTSC and HDTV transmissions. We have the bandwidth on 70 centimeters here to do that. If you're interested, contact BARC, Boulder Amateur Radio Club, W0LEB.
Well, Dave, you've got some electrical noise coming through on your transmission there. Didn't hear it before, but do now. K0PRB.
Yeah, I was going to mention the same. You had a little bit of, what sounded like electrical noise on that last.
Oh, nuts. Is this any better?
That is somewhat better. I still hear it a bit in the background, but it was definitely not as pronounced as the last transmission.
Okay. It is. I'm going in on a 750 Lee Hill. Yeah, the slow scan is NTSC standard, although less resolution. If you contact the Boulder Amateur Radio Club, they do support both NTSC and HDTV broadcasts on this band, 70 centimeter, but that's contact the Boulder Amateur Radio Club, BARC, for information. They have a net every Thursday during work time on the 14670 repeater, W0LEV.
So, Dave, do you know what equipment that I would need on my end to decode a signal like that?
All you need is a receiver that will cover that frequency. It's within the amateur bands and an HDTV receiver. That's all you need.
Very cool. Any other questions about any of the stuff we covered, or any topics or modes that we haven't covered? Please call.
Thanks for the clarification on the television transmission formats available to amateur users, KE0TDK.
Absolutely. And it sounds like we didn't have any other questions about the various modes. Does anybody have any general questions? Let's move into general questions for the TechNet before we end the net. There were some questions on antennas. Did you want to pose that to the group?
I think I'll hold off a little bit. I want to do some more homework, and I haven't got the equipment at this point anyway. This is first piece of radio equipment in the amateur bands that I bought that I'm using tonight. So I need to talk with my budget manager with regard to extending my capability.
TDK.
Oh, I definitely know that game. Check in with the budget manager is definitely important. Yes, we try to put in a talk about the or general questions at the end of each of the tech nets, and we also are getting into making a open topic once a month. So we would definitely love to get those questions as they come on. Any other questions for the net on the various modes that we've covered, or any general questions? Please call. Hearing none, I want to thank everybody for participating this week, and it was quite a good talk. I learned a lot. I always enjoy the tech nets when we get into topics that I am not the most familiar with, because I get to learn a bunch. It looks like next week we are going to be discussing Echolink and IRLP, the types of stations, the abilities of each type of station, how to connect, and hardware I need to be able to do Echolink and IRLP. So tune in next week and definitely get involved in that conversation. Does anybody have anything else for the net before we close up for the evening?
1 DEG.
Yeah, go ahead, Mike.
Just add me to the count. I was monitoring. I just missed the check-ins, so I just waited until the end. K1 DEG.
No, I got you on there, and yeah, don't worry about catching those first check-ins. Feel free to jump in anytime. Anything else for the net before we close up for the night?
N0 WIQ with a comment.
Yeah, go ahead, Carrie.
Ever since they started putting processors in our amateur radio equipment, they have extended the features of the radio. And one thing I've noticed about computers is, a processor is a computer. Just some of them are set up for different things. So, so this computer age has really been wowsome. So anyway, with a computer, you can take any piece of data and make it display any way you want to. Well, when it comes to amateur radio, like with the narrowband and wideband they were talking about on HTs, nothing says that they go away from the narrowband for transmitting, although there was an audio difference. It might be the data format that put the audio in more than the actual wideband or narrowband part of it. But on the other hand, you can do a wideband FM for listening, because you can tune down to the 100 megahertz band and listen to the FM stereo and all that kind of stuff. Of course, you don't usually have a stereo output on your amateur radio, so that might be a little bit worse off. But on the other hand, you can listen to it quite plainly. So anyway, that's my comment.
Yeah, I would definitely agree with that. As the computers and technology has gotten smaller, faster, and cheaper, it has definitely expanded our capabilities on what we can do with various things. Raspberry Pis and Arduinos just scratch the surface of that world that we can get to play with on the small computer systems, for sure. Any other comments, questions, or anything for the net before we close up for the evening? Hearing none, I want to thank everybody for participating. Definitely a good net tonight. I'm going to have to listen to it again and go back over it because we covered quite a bit of good stuff. I want to remind everybody that we do stream these nets onto YouTube. So if you missed anything or have any more questions, feel free to jump on our YouTube channel, youtube.com/NCARC, and review all of our nets. And if you have any questions or would like to pose a topic for the net, please email us at elmers@ncarc.com. That's Echo Lima Mike Echo Romeo Sierra at November Charlie Alpha Romeo Charlie .November Echo Tango. I want to thank everybody again for participating. This net will meet again next week, Monday at 6 p.m. And our topic, like I said, was Echolink and IRLP. This is Whiskey Zero Delta Delta Zulu with the Northern Colorado Amateur Radio Club TechNet. We will be signing off. The repeater is now open for general use. Thanks and have a great evening, everyone. This presentation was brought to you by the Northern Colorado Amateur Radio Club. Thank you for watching, and don't forget to like and subscribe.